Hello, today we study in chapter 10. In this chapter, we will learn about the process and scheduling in the operating system. Okay. Inside the operating system, when you open an application, the the application after you click the open, the application run on the memory we call it is process. Inside the process have a thread and sub-function inside the process. And when you run 10 applications on your system, Windows must schedule to select an application to run on the CPU. That is a brief about the before moving to the detail in this chapter. After your study, I think you will understand about the mechanism of the process and problem of the Stack Overflow. And you can explain the scheduling techniques in the operating system. And you recognize and also have an experience to queue and adjustment the priority of the process in the Windows. We have 4 topics for study. First, we will learn about the process and the inside the process creation when you are after you click the execution file and how to change the priority in a process and how to queue the process from the memory. And maybe when you run an application and your application have a problem to you cannot do anything, it is about have a problem error, you can use the queue command to turn off the application. And inside the application, inside the process have 4 parts, that is text, data, heap, and stack. There are the detail in the inside the process. And finally, you will understand the scheduling techniques. Now we will move to the detail about the process. In this picture, I open an application. I suppose I open an application. I suppose I open an application 7-zip. 7-zip is a zip program. 7-zip by click the execution file. After I click the execution file, the program will load into the memory. Here in this. Sorry, I have a problem about using mouse. I use the digitizer and have a problem to select. Okay. Okay. When you open an application, example, I open an 7-zip program. I click the execution file here. After I click the execution file, the window open the file, open the binary data from the file, and push all the binary data inside the execution file to the memory. We call here in this is active application or active program. When you click turn off the program, the data inside the program will write into the memory and remove it from the memory. We call this is this active application or turn off the application. When you click and download and run the program, inside the program have 4 parts: stack, heap, data, and text. Stack, heap, data, and text inside the memory. Here it is, we call the process. Exactly when you open 10 applications in your memory have, this is similar to this, about 10 applications. Example this here, 10 application. When you open many applications, over 10 applications, and not enough for load on your memory, Windows can save your application to the hard drive by use a temporal location. After the application have selected by the scheduler, the application will reload to the memory again. Okay, now this is activity 10.1. Here in this activity, I will show you on the window and show you the list of the application run in the Windows system. Now I suppose I open the notepad and then I use the CMD, that is command line dialogues, for use the command line to look at the detail of the process on your memory. And then I use the task list to get the list of the application on memory, and use the TSQ to queue or turn off the application. And some version on Windows, you can use the task queue and put your ID to turn off the application. Now I will show you how to show the application on the memory. Here, this is video file. Sorry. And here, this is my video file. Okay, yeah, this is example. I use on the window, I click at Task Manager, and then after I click the Task Manager, the Task Manager will show the application. Now here, this is application on my system. I open the pen brush, and here this is pen brush. Now I click the Go to Detail to look at the detail of the pen brush. Here this is the pen brush, and I stop the video. Again, a pen brush. Look at the video. This is a location of the pen brush. Here it is. The pen brush is, and in each application, when you load on the memory, it will have the PID. It look like the ID that is not the same ID on the system. Now my pen brush have the PID as 16564, and this status is running. And the pen brush use the memory about 5600 kilobytes and not run in the visualization. Okay, now I click at the pen button. After that, I can set the pen button by setting the adjustment of the priority. Now here, wait a minute. Here it is. I set the priority. On the priority, when you click the right mouse on the pen bar or some application, it will show the priority, set priority. Now you can change the priority from low, below normal, normal, above normal, high, and real time. When you click at the real time, maybe these applications hold the CPU time about the 100%. 100%, but not really 100, because a little bit time is used for operating system. I think it's not 100, maybe 95%. And when you open for use in without the setting, the priority will set in normal priority. Some applications, such as virus scan, antivirus application, it will set the below normal priority for slow running, and maybe some application run in background set at low priority. Now I can change the priority, and now this is authority. What is the authority? In my system have a 4 core, core 0, 1, 2, and 3. Now I select all of the core. That means the operating system will automatic select my application to run on core 1, core 2, core 3, or core 0, depend on the operating system selection. But if I need to lock to lock my application to run only a core, example, I select at core CPU 0. That means this application will run only CPU 0, number 0. Here, this is my system have 4 core. Now I look at my system. This is small graph, and I can show. Now here is this. This is show kernel time, kernel process. Kernel process is the number of the process in about the process of the operating system. That means here this is operating system used, and this is total. That means when you are subtraction from this to this, this is here distance from this to this. That is for your application CPU time, and in this is OS CPU time. This is on the Windows system. And Wi-Fi. For Wi-Fi, you can click at View Detail and check your Wi-Fi speed. Now I use Wi-Fi connect at 300 megabit per second. In some application and some system, maybe connects lower than 300 megabit per second, depend on distance from your computer to the network router. I think this is complete for this video. And now I show you the next video here. In this activity, I will open the notepad and queue the notepad. Now I click open notepad. Here this is notepad. And then I use the command line dialog, click start and type the CMD. Now I open the command line dialog here, and I use command task list, typing the task list here. After I type the task list, this is a notepad application. The notepad locate have a PID at 2000, maybe 2020, 2028. That is PID. Now I use the TSQ command. I need to queue the notepad. I type the TSQ command. But here it is have a problem because my window this is window on my notebook in my laptop that's use a window home version, not a professional version. So I try to test author command. This is not respond. Here is I check my system on Windows. Here is I use Windows Home single language version. Have a problem for use the task command. Now I change the window to test on the Windows 10 Professional. Here this is Windows 10 Professional. And now I open Notepad and Pen Brush look at the video. Now I open Notepad and use a CMD. I use the Windows 10 Pro. Click Start and then open Notepad. Now I open the CMD and use task list command to get the task list on my system. Now here, where is the notepad? I cannot find it. So I try to find the notepad but not found it. And then I open the pen pad here. After I open a pen pad, I found that the notepad, that is the PID of the notepad. And now I use the command task queue. Here is this task queue notepad. The notepad stop or terminate from the memory. Now I use task queue in the PID for the Microsoft pen pad. The PID is 116.11760 and not response, not command for Windows Professional. So for here, we can conclude that the window, you can use the task queue, task list for turn off the application. Okay. Now here, this is activity 10.2. I think we will skip because this is example. I show you how to change the set priority. You can set the priority on your application. Example, when you open the game application, and you need more computation, you set the priority at the high or above normal. The game application will hold the CPU time over normal process. Okay, now in this slide, I compare between the single core and multi-core system. On the left hand side, and suppose you have a CPU in single core system and you open for application A, application B, application C, and application D. You have only single core CPU. Single core CPU example, the first version of the Pentium about 1995 to 2000. That is the era of the first of the single core Pentium. So in this system run in the single core, the single core, when you have a full application, is need to switch by running the application A in a short time, then move from application B, load application A, load the application B to the memory, to the CPU for running, and then load the application C to run on the CPU. After that, moving back to run the application B and application D. So here the select the application is depend on scheduler. This is a work of the scheduler inside the operating system. I suppose if I set the priority at the real time or high, that means your application will have a long running time. In example, in this application C set the high priority, so the application C hold a long CPU time. On the right hand side, this is a multi-core CPU. I use the same problem. I run application A, B, C, and D. But my system have a 4-core CPU. The operating system can use the scheduler by easy for running in the scheduler. By scheduler, set the CPU, the first core running in the application A, second for application B, third for application C, and the fourth in the application D. So when you buy a new system, a new computer, if you select your multi-core and have a 16-core CPU, that is exactly your application have a high performance for running in more application when compared to the few core, single core or 2-core CPU system. Okay, now when an application load into the memory, it have a process state. What is the process state? When you open an application load into the memory, the application have a 5 state for running. By the first, that is create, ready, running, block, and exit. Not exactly for 5 states, it depends on the operating system. And this is a concept for the process state in the operating system. If you look at the hardbook of the Linux or Mac OS, it is maybe not 5 states. That is depend on designer of the operating system. Here, this is a concept. Now, I suppose I click the execution file for running. The application will move to the create, and then after that is moved to the ready. The ready is a application ready for select to runnings and waiting for selection. Example, the application A waiting or application B waiting. And then after that, the application A have a the application A is selected by the operating system to run on the CPU. Is changed state from ready to running by this path to running. That means look like this. Application A run on the CPU. And then after application A run complete, it will move state from running to exit. The exit of the data from the application and inside the memory is will write to the hard drive on your hard drive. And if you have the application for use the CPU time for use a really long CPU time for running, maybe the application running about the 10% of the works, not complete the works, the application will move to block for waiting to coming back for running again, to box and move from the block to ready state for select in future. And exactly the operating system will select other application to run in the CPU. I suppose in your application connect to the I/O, example for keyboard, mouse, internet. Some connection to the I/O device may be waiting for very long time. Maybe when your application wait for response from the I/O, it will move from the running to the box. It is look like and run on the running end of the time for selection. Okay, here this is a process test on the and in an application for running. we can conclude that this have main file state, create, ready, running, blocks, and exit. Now we will look at the inside of the process. When you load an application to the memory, inside the process have a 4 part. Here this is inside the process. Moving back to look at this picture. Here in this, I open 7-zip and window write the code of 7-zip to the memory. It have a location on the memory. Inside the scope, here this is the scope for 7-zip. The scope inside the scope of the 7-zip have a 4 part: stack, heap, data, and text. Stack, heap, data, and text. What is text? Text is a binary code program. Code program example, I open the 7-zip. The code inside the 7-zip will write here. This is text. And some variables, global variable, for using in the use for communication or transfer data between the sub-function in the application, will locate in the data zone. And we call this data. And the third we call heap. What is heap? Heap is its dynamics memory. Dynamics is mean heap can grow up and reduce up, going up or reducing size of the heap. It depends on the application using. Example, when you open, example, I open a launch file and I zip the launch file. Maybe heap is going up to process a launch file. And the fourth, that is stack. What is a stack? Stack like as the keep, but the stack is a temporal memory for program moving to the sub-function. What is the moving to the sub-function? When you write a computer code, you cannot write only single function for running the program. You need to write and split your program into the small sub-function, like this, small sub-function. When I run to this function and move to this function, and the next I move to this function, and the next I move to this function. I move 1, 2, 3 hop, and when I calculation complete, I need to moving back from here to here and to here and to here. When I'm moving back, I need to return the value before I'm moving. So that means when you are moving to a function and moving to the function to any location, and when your calculate finish in a function inside in deep, it is moving back and return value, move to the part of your way, to the part of the way that you are moving for in and out. Look like this. This is moving in and moving out into the same part. So when you're moving to the many function, a lot of function, the stack will going up, but not going up inside this, but this is going up, look like going down. So here this is some application when the programmer write the code not careful about the bugs, it is maybe generate stack overflow. Stack overflow, that means the stack going up until hit to the heap, until hit to the heap. Is after it's hit to the heap, your application will terminate or turn it off. Okay, so I will conclude that inside the process have four parts, that is text, data, heap, and stacks. Both stack and heap, when it is going up, it may be stack overflow or heap overflow. Here in this is example. Example I like in C language. In this C language, I declare a main function and I declare a variable x. All of this code will keep on the text. And the second, I suppose I declare a variable g. The g, I suppose, is global variable. Because the global variable, you declare the variable outside the function. Here, this is a scope of the function, but here in this is a global variable declaration outside the function. We call here this is a global variables. Is keeping in location of the data. And in C language, you can use the command malloc. Malloc is its abbreviation from the memory allocation. Memory allocation. And this is size for allocation. I use the size is 4 byte. 4 byte, that means it is size of 4, is it 4 byte? 4 byte multiplied by 8, that is, and that is 32 bytes. That means the heap will use the 32 byte for allocation and keep value for asterisk I. This is a location for variable asterisk I. When you open, example, I open a large file, I open a picture that is about 1 megabit, 2 megabytes. The picture 2 megabyte size will keep in the heap. Exactly, heap will going up and down depend on your application. And exactly, if the programmer don't have the experience to manage the heap or memory, it is maybe they declare the malloc allocation of memory and not return the memory. Programmer need to return the heap before moving out from the function or turn off the program. If they don't return the heap, maybe the heap full. This is occur when you use a C language and really old programming language. If you use in Python and programming, you don't care about the memory allocation because it's management by the compiler inside the Python and programming. The fourth, that is stacks. Here in this, I declare a function A. A function A called by main program. When the main program run here and is found the function A, the program will move to run in this. Before it's moved to run in the function A, it will keep the variable A in a stack. Keep the variable A in the stacks. After it's running in function A complete, it's moving back to run the remaining command. When it's moving back, the A that is temporal here will return to the main program to running for the remaining the command. Exactly. When you have a lot of function and move the deeply. Deeply, that means I move to the function A, and inside the function A call the function B, and inside the function B call the function C. That is very deep. When you call the very deep function, every every time you move to a function, all the data or the variable will keep on the stacks. When you're moving out, the data that keep on the stack will return it back like this. So here this is in this activity I will show you and the problem of the stack overflow. Exactly, we don't have a compiler on the system. I will use the online GDB and run in this application. Now in this activity 10.3, and in this activity we will test this course. And before we move to the next topics, okay, please open a browser and type this code to the online GDB website. Follow me. Now I open the online GDB and then I copy all of this code to this program. Here in this, I write the course and void function. I use a small name f fun. Okay, now I declare variable I, variable j, and j printf %e \n j. And here this is function. This line is very important. Look very carefully. What is this? What is this? And here in this, I type this function and I put value 0. Before I run in this code, I will explain this course. Now in this course have a two function, function fun and function main. When you run C language, the program will start at the main function by default. Here when the program start, is moved to the fun function. Move to here. After move, and when you move to the fun function, inside is declare variable j at 1, print j value. It is not important, but this is very important. Okay, sorry, this is my phone. And moving back, and this is after here in this function, as is very important. When the program run in this line, it will call a function. This is function again. That's after that is after run to in this line again. It's called this function again. We call in this function, in this technique, we call recursive. Recursive, that means a function call in itself. But here in this recursive have a error because it is called in very deep function, not stop, because when you look at this code, it is look like infinite loop, because it is called this function infinite, but not infinite because every call the function, the program will keep variable j in the stack. So when it's run to this about I think in about 10,000 times, 10,000 times, or maybe 100,000 times. It is maybe stop because it's Stack Overflow. Okay, when it is called, it will spin the calling the function. I type here call time calling number here in this. Now I set the language as C language and then I click start. Here in this I forgot the semicolon, and here now the program run to 2000 24,000 a stack not overflow. Very large stack size. Oh, not overflow because it's very slow because in this line have a problem because pin F is CPU spend its CPU time to display on the monitor on the console. So maybe I stop and I use this if function. If I mod 1000, everyone 10,000 is will bin skin every 1000. No. 1000 0 is here is this program finished which exists. This is stop because it's run about 170,000 time, and then the program stop by termination because it is a stack overflow. Here this is example for stack overflow. Okay, here in this I capture here, and the program shows segmentation fault because it's stack overflow. It happens stack overflow to hit the heap. Okay, here this is I show you 4 parts: text, data, heap, and stack. Now we will move to the detail of the scheduling techniques. Okay, now we will move to the topic of the scheduling techniques. Here, before we detail the scheduling techniques, the T-level scheduling in the computers. When you have a job, a job will operate by the operating system to the input queue inside the operating system. The operating system will manage the queue, the sequence of the job queue to run on the memory. And also the operating system select the data or the job in the memory to run on the CPU. In this, CPU select by the scheduler from the operating system. And maybe when the memory full, the memory use the memory scheduler to keep in another part in the hard drive. The operating system will hold or control CPU, memory, hard drive to manage the queue by scheduler. So here the job hold in the input queue until move into the memory, right? And CPU scheduler pick the next job to run. Memory scheduler pick some job from the memory and move to the disk if insufficient memory space or full. Okay, we can measure the scheduling performance by three methods. The first, we use the throughput. What is the throughput? Throughput is the amount of works that is complete in per second. That means when a worker is working by 10 job, 10 job in an hour, that is throughput. And when compared in another worker that can work by 15 job in hours, that is more throughput. And the second, that is response time. Response time, that is time for complete the works. That is response time is the time from when a command is submitted until results are returned. Getting the result to return the supplier. Can measure in the average value, variance, minimum, and maximum response time. This is response time, not throughput. Example, and so in throughput, I show you and I mentioned about the 10 worker that do the 10 job in an hours. But a job to the worker may be finished in the 10 minutes. That is minutes. This is the response times. And the third method for measuring the scheduler performance, that is turnaround time. Turnaround time is like as the response time, but is used for batch job. That is long waiting for the next turnaround. That is waiting for until the works finish and launch again, which is we call turnaround time. The scheduling techniques divided in the scheduling techniques have four techniques. That is the first we call first come first serve. The second, this is the shortest job first. The third is lobbing. The fourth is priority scheduling. Now the first come first serve. First come first serve. Look at this picture for easy. We have a 4 job. Job A, job B, job C, and job D. Job A spend 4 time. Job B spending 3, C 6, and D 3. The first come first serve. That means which job is come first. So here the first job, that is A. The A execute first, and then B, and then C and D. By order, this is first come first serve. The first come first serve, this is fair in the same way a bank teller line is fair. It is simple algorithm for develop first come first serve, but the first come first serve have a problem. Example, when I land in the C spends 6 times or 6 seconds. So it is C holding a CPU time over A, B, and D. Many process may wait for a single long job. This is problem for the first come first serve. The second, that is the shortest job first. We have the job same in the first come first serve by A4, B3, C6, and D3. And here in this, the operating system will manage by select which one is very small. By is select D to run first. and then select C, and then select A, and then select D, select C. In this is the shortest job is run first by the first job. The shortest job may be completed first by using a few time, and the long job may be delayed for run in later. But it is the problem because some job cannot ordering. Some job cannot ordering because the job you need to see all of the job, and you can predict in each job that's use a time for in each job before you're doing in the first in the shortest job first. So the shortest job first is primitive from the shortest first have a problem that I told you the operating system need to predict which job is run shortest before running. The third we call Lobbing. The Lobbing key is give a process in a fixed time. That means, example, the process A is very large. It will split to the small part in a fixed time, and run in rotate in ready process by the small part of A run here, and the second part in small run here by Lobbing selection. This is a good for select in when you have a large process and you split in this small time, that is called quantum. Too short in many process service in huge efficiency. Too long. Some process is poor response and interacts. And typical every time in here is used about 10 to 50 milliseconds for running in each job in Lobbing. Finally, this is priority scheduling. The priority scheduling will schedule the job by select by priority. Some jobs have a very priority. Example here in this, in the pink have very high priority. It have a high priority to run on the C2 selected or run on in the CPU. And some job as is in low priority, that is waiting for running in the CPU. In the priority have a priority queue. Here in this is priority queue. Maybe when you have amounts of the job will be classified by priority and have in the queue line in here. When I have a very amounts of a job, jobs. The job will determined by the operating system which one is high priority and low priority, and distributed to the each queue. And then after in this job in the queue will selected to run in the CPU. The priority scheduling has a ready process with highest priority allowed to run. Running process may be interrupted after quantum time. And maybe example in here in this job is not complete. After is not complete is moving back to the queue again. Here in this like this. Priority may be assigned by dynamic calling, maybe can change to reduce priority or increase priority, depend on the operating system. Reduce when a process use a CPU time. Increase when a process wait for the I/O that is depend on the operating system. Here in this chapter, I will conclude that I think you understand about the process, and process create priority and how to queue the process. Inside the process have a text, data, heap, and stack. And also, a little bit about the scheduling technique for schedule the process to run on the CPU. Okay, now I think you have a detail complete in the chapter 10. And bye bye. See you next chapter.